Any second now. How about now? Hey, this is it, everybody. Our big 100th program. Welcome aboard the morning of January 23rd, the year of 2023. I'm Baron Ron Heron. Actually, I've sort of dropped the Baron. I'm not on radio anymore, but used to meet with these guys on a regular basis. Same members of our South Coast Longtime Astronomy and Telescope Club called the Santa Barbara Astronomical Unit, which used to chat with me twice a month on the radio. Anyway, happy to be vice president, reelected. We're going to introduce you to the brain trust here in a minute. This is the SBAU Astro Hour number 100, because we started this on Friday, the first day of March 21, I guess it was. No, or what would it have been last
21.
year? 21?
Yeah.
So it's been over a year. Wow. This week, we're going to talk about the comet, Big Green Weenie. Won't be back for 50,000 years, so get to know it and say goodbye. We're on a schedule for NASA's landing of humans on the moon. Several solar eclipses this year, and 3 types of eclipses. I didn't know that. I learned a lot from this, hosting this show, everybody. You will too. We got lots of diagrams and pictures and stuff from Jerry's talking points. Used to be 3 kinds of galaxies. Now we're going to talk about a 4th. And a week from this Friday night, February 3rd, in the Museum of Natural History at Parent Hall, our big general meeting, going to feature Dr. Joseph Bassi talking about space weather. Good morning, Mr. President. Jerry Wilson.
Good morning.
Married to Pat Corgi, and he's got his own little square box observatory in the backyard that works just fine. The roof goes on and off, I believe you told us in December, sir.
Yeah, rolling roof.
How is Pat? How's the family? You got
Everything's good over here.
all right. Chuck McPartland's also married to a Pat, outreach coordinator. Pat McPartland is the merchandise manager. She shows up sometimes. Here is Bruce Murdoch, longtime active member out of the hospital. He actually sat in his hospital bed last week and talked to us from Cottage. And he's also president of the Santa Barbara Theater Organ Society. His wife is Bonnie. Real quickly, Bruce, you want to tell us what's going on when we can hear the organ in Arlington?
We just had an open console this last Saturday.
Oh,
About a dozen people showed up, a lot of newcomers. It's
all right.
open to the public. It's free. It's typically the second Saturday of the month,
All right.
except if the theater has something going then we move it forward or back one Saturday.
And you haven't planned any future?
Well, I can't get a date this early. I have to wait until basically the beginning of the month to call the manager and find out what's going, because whatever comes in and pays money.
Right,
usurps that.
sure. And since we smell bread being cooked, former Westmont College science instructor, Tom Whittemore, editor of our
Morning.
news.
Morning. Yeah, no bread this morning, though.
Is it in the oven?
Nope, just soup.
How's Maureen?
Oh, fine. She's out with Wally right now.
One of the people that does listen to us, we have about 100 watchers off and on, and you can see us on YouTube like 20 seconds later. But all the archive shows you can go on sbau.org and see. But Tim Crawford's got a birthday, I said. I believe you were telling us, right?
Yeah, he just signed in on text here. And Jim Williams is on, he said. And he said his son Jason weighed his cake, and the cake weighed 6 pounds.
That's because of all the butter in it.
Tim's blaming it on the raisins.
That's 3
Raisins, yeah.
bread, Chuck.
Raisins with carrots.
Yeah.
Have you ever made one of those, Tom Whittemore? What do you do? Grate the carrots? Just like you do potatoes?
Oh, carrot cake? I've not made that. I've made New York Times recipe-based chocolate cake, things like that.
Oh my God, Father, forgive him.
I do like carrot cake a lot. I like it a lot.
Whatever the electronic birthday card you sent to Tim, it probably would have looked good among President Jerry's silly science cartoons he forwarded, because he caught up with a dearth. We had only 3 last week, but that's fine. We like to start this program every week out with a little silliness, a little levity. And here they come. I hope I can match. The stick figures. That would be 2 guys talking. No, this is 1 guy. Which one is this? Equation? No. It's artificial. Australia, Lance. Oh, walking electrical. No, that's not it. At the beginning, God. Is there 2 figures in this?
Can you see what I'm projecting?
It's
Yeah.
barely there, but I didn't really understand. There's a guy in a stick figure that's pulling a
lever. When he pulls the lever, he gets zapped with lightning. And he's sitting down in the third circle. He's sitting there with his hair smoking. And then
Right,
it forks into what a normal person would do, which is, I guess I shouldn't do that.
exactly. But
And
a
a
scientist,
scientist which says, I wonder if that happens every time. And he goes to pull the lever again.
it's AI striking his back, artificial intelligence, which here we go. This is the bent rocket. Australia enters the space race on the launch pad. It's bent in the shape of a boomerang, of course. Yeah, it's a strange shape, but I guarantee it'll come back. The Australian, I wonder why they're not entering the space race. Everybody else is, even India. Here is, of course, Snow White peering through the lens of a telescope. Whoa! And the scientist nearby, he doesn't care. I know Snow White sees another dwarf star, since you wouldn't see a dwarf planet. Oh, well, no, she might. And make that, oh, the two cats talking. Cat genius. They're at the science blackboard perusing some strange formulas and diagrams. One cat using a pointer says, yes, it's highly complicated, but it's actually possible to capture a laser dot. Because I'm sure all you guys have laser pointers for your kitty cats.
Oh,
Here
yeah.
are 5 gnomes. I thought these were continued the dwarf thing, but these are the gnomes.
Yeah.
It's called the polynomial equation. Is
Oh,
that
no.
accurate? Yeah, polynomial. We won't solve this, guys, unless we all work on it together, okay? Polynomial equation. Is that correct on the blackboard?
No,
No.
It's not.
no, it's baloney.
All right, here is God himself with the entire universe packaged in a
I
bundle.
like this one, yeah.
Instructions read, let's see, I pull the handle A from bundle B, and then the item will expand somehow. They don't have that in Genesis, do they? Ah, the walking electrical cords, walking by the male next to the female extension cord socket, passing a bunch of obsolete, now useless electronic computer and audio cable connectors, lost and out of work. And he says, don't make eye contact. The other plugs.
Yeah, these are old RCA connectors. And these two are serial port connectors. And these are common on telescopes,
Are they?
especially on astrophysics mounts, because they're very good at keeping the weather out of the connector.
One of them might be a VGA video connector too.
Yeah, up there.
Well, actually, the bottom one, I think.
Oh, you think the bottom one?
Yeah, it has more pins in it.
Yeah.
Well, I dealt with the RCAs a lot during my mobile DJ career, but those computer connectors, I bet you they're going to make new ones. You know,
They're making ones all the time,
yeah.
Well, it's all USB now.
Here are the two stick
except for
figures.
Apple.
How a layperson or a scientist would respond to being, no, that's the Zap thing. Where is this one? Trying to create an AI, artificial intelligence, that can understand and use sarcasm. And the lady visitor says, well, how's it going? Oh, it's,
That's
I
the
guess
machine
it's the
talking.
computer. Yeah, then now the computer answers us. It's going great. This guy is a real genius. Well, was that sarcasm, sir? I don't know. Could have been sarcasm. But all they need is a red lens, like from 2001. Okay, gets us in the silly mood for learning stuff. It's just amazing how you come up with these things. And nobody wants to tackle the lunar year thing. Actually, Chuck explained it to me, the lunar calendar of the people in China and Asia, because
Well, there's several, like I said, yeah.
yeah, because the month that a moon, it takes 28 days, not a whole month. And so it doesn't add up to 360.
It's like 29 and a half if you go from phase to phase. So
Right.
We're going to the
20,
sky.
27.3 if you don't.
Okay, here we go. Camelo Pardalis is being pointed at.
that's got to be one of those horrible astronomy finder charts.
Yeah,
I
that's
thought
all.
with Polaris prominent up here, you wouldn't object too much. It's easy to rotate around this.
But
So
is it accurate? Is every dot accurate?
it's loosely accurate.
Yeah.
Sky Telescope has a very, very good view of this. So next weekend is the weekend we're going to start looking for it with binoculars.
Mhm. So it's up in a region near the North Pole where there's a lot of galaxies, M81, M82.
Mhm.
M 102,
And
5907.
then later in
M101.
February, it's going to go quite close to Mars.
Okay.
Hmm. So it's going to be around for a while because it takes 50,000 years for its whole orbit, right?
Yeah.
That's got to be.
This is a picture taken. The words on the truck are all in Spanish.
Mhm.
So I think it's taken from, I don't know. You could probably tell the latitude by how high these things are, but
Mhm.
the comet is up here.
Well, where did you get the picture?
It just popped up on Facebook.
Oh, somewhere in the Southwest.
Mhm.
Don't have too many Spanish trucks back east, as far as I know.
It could be Mexico, could be South America, could be Spain, could be, yeah.
Yeah,
Could
could
be
be
here.
Spain or South America or Mexico. I doubt South America. Well, it could be northern South America.
Mhm.
Yeah.
Can you make it a little bigger?
This shows what it looks like in a very wide angle, just a simple camera.
Mhm.
So it's an easy object to spot and easy object to take a picture of. You can almost see, or at least imagine, two tails, but you
Yeah.
can certainly
Mhm.
see one prominently.
It's nice.
I got a call from somebody, you know, the media is really hyping it up as an emerald comet and
Yeah.
C and all this. And I got a call from somebody and I had to say, look, you're not going to see that visually. That's in photographs, you know, it's not, don't expect a spectacle.
It's not green when you look at it through a telescope.
Not with our
Not unless you
eyes.
have a really big one, no.
Yeah.
Well, has
It's
it
not
been
bright
green?
enough to excite our color vision.
Yeah.
Has it
It's
been
green in
green?
any image you take with a camera, with a sensor, but your eyes don't integrate, so you don't see it. You might get a hint of it, but you're not going to see it the way it is in the photos.
So all comets have two tails,
At least.
at least.
Yeah.
Okay, one points directly out from the sun, and that's the solar wind hitting it.
Well, one's
That's
an
the ion
ion
tail.
tail of charged particles, and that's going directly away from the sun in whatever path the solar wind is taking. And then there's a dust tail, and that also points away from the sun, but it curves under gravity. It's following the same orbit as the comet.
That's right.
So that tail would be in the line of the orbit itself, pretty much. It's like trailing behind it.
Kind of, yeah. I mean, it also gets affected by the solar wind, just not as much as the ion tail.
And sometimes they have an anti-tail.
Yeah.
Mhm.
And often the anti-tail is just, it's got a fan-shaped tail, and you're looking dead on at the head of the comet, and you see the fan-shaped tail on either side.
Mhm.
And the anti-tail would point forward,
Yes.
Mhm.
for crying out loud. Well, which ones have we got stuff off of? Was it us or the Japanese that went and landed or we landed on an asteroid, I know, but we haven't done that for a comet, have we?
We had a mission that went and collected comet dust using aerogel,
That's right.
and that brought back some samples. And then there was the European Space Agency mission, the Churyumov-Gerasimenko, that landed on the comet and took a lot of measurements. They didn't bring anything back.
Mhm.
Okay.
That's the one where the lander slipped down in a crevasse, didn't it?
Yeah.
And so its solar cells were shaded a lot and it finally died.
That
And
wasn't on an asteroid.
they actually took the main spacecraft and bumped it down onto the comet too at the end of the mission.
But you could see it and wasn't blinded or filled or totally surrounded by the cometary exhaust or whatever makes
Well,
that.
that stuff is amazingly tenuous, Ron. I read somewhere with Hale Bopp, you remember how big the tail looked on that,
Mhm.
that you could take all of that material and it would fit into a suitcase.
You're kidding.
No,
And it's mostly water vapor. It
There's
was
water
ice.
vapor, there's other gases, and there's dust too. So
Huh. So it gets hit by the sun's outward solar flares. What do they call it? Solar wind.
solar winds, yeah,
Yeah.
and just sunlight heating it
Yeah.
up.
And asteroids don't do that. Why?
Some asteroids do that. There's a continuum of stuff between asteroids and comets, depending on how many volatile materials they have in them.
I just had the
Oh,
impression.
yeah, yeah.
I just had the impression that asteroids were bare ass rocks and comets were loaded with stuff out in the Oort cloud or Kuiper belt.
Yeah, but there's stuff in between.
Is there? Do we ever get them out of the Trojan belt of Jupiter's orbit?
Maybe, I don't know. Not that, no, I don't think any that we've tracked back, but it's possible. The reason they're interested in those Trojan belts is they think that they get disturbed a lot less and that they may hold primordial material. And that's why they want to go look at it. That's why they called the mission Lucy.
And all those rocks are part of a Lagrange point in Jupiter's orbit, aren't they? Kind of, they're locked in.
One
there.
on either side, 60 degrees. Yeah.
Did NASA just launch, or are they still about to launch to go there?
No, that one's on the way.
That's on the way.
And it's Psyche, the one that's going to the metal asteroid, that's asteroid Psyche, that is just about to launch.
What's the new one called? Juice.
That's the Jupiter Icy Moons Explorer. That's
Oh yeah, that's right. It's
moons.
going to 3 moons of Jupiter. Just the moons this time. Interesting. It'll probably do with Jupiter. Well, actually, we got one around Jupiter, but the Cassini went everywhere around Saturn, and they want to do the same thing probably with the JUICE program, the JUICE mission, I imagine.
around those moons. Yeah.
Interesting. Fascinating stuff there, Mr. President. The wandering long-term green comet. There's probably several other comets. Where are we going now? Starship?
Starship to the moon.
There we go. Artemis 2 is not here yet, or hasn't happened. Artemis 1 did it. Artemis 3 you're talking about, that's with the live people.
Artemis 3 is the first manned effort to put people on the South Pole of the moon by the US.
And we'll all be 2 years older
Yeah.
when it happens.
If we're lucky.
Yeah.
If we're still here. Yeah.
Well, no, just meaning that if it holds to schedule.
Yeah.
I mean, they're relying on this Starship, which is still pretty experimental.
It hasn't flown yet.
Yeah.
So, matter of fact, one of the things they're looking for this year early is to see the full up Starship with a gigantic booster. The Starship has flown suborbitally, but with a giant booster putting it into orbit, that's the next step. And this shows the lander stage that SpaceX is building for NASA. And this is the not Apollo. This is the Artemis 3 capsule there with its, service module behind it.
The thing on the tip, is that what's going to land on the moon?
Yeah.
That's
This is what's going to land on the moon.
Oh.
And this is going to stay up in orbit.
Oh,
Is that right? Let's watch and see.
Yeah.
it's going to move? It's not a video.
No, it doesn't move. We're going to move.
Okay.
Now, the numbers are hard to read, but they're in order. You can count down. It starts over here with the green line, the light yellowish green line. And here it is, the SLS and the Orion lift off from Kennedy Space Center. Now, that's the complete NASA rocket that has been launched already once and has gone around the moon. So this one with the capsule, that's developmentally advanced than the Starship is from SpaceX. Then up, where is it? Number 2, 1, 2, right there. Going to jettison the rocket booster, fairings, and launch abort systems. Then, as we're getting up into orbit, the core stage main engine cutoff, core stage SECO, core engine cutoff. The first one is MECO, where the that's MECO. This is MECO. Well, I've got them mixed up. Forget that.
Can't get there from here.
Yeah. Core stage main cutoff. Then it enters Earth orbit. So as it goes around the planet, it's in Earth orbit.
Mhm.
Now so it disappears around there. It comes around here and injects itself from Earth orbit into translunar orbit.
Mhm.
So it heads out here, heading to the moon. The Orion outbound transit to the moon. That's the Orion capsule. Orion outbound powered flyby of the moon, 60 nautical miles from the moon. So it goes around the moon, and then it goes down into this
Lava tube on the South Pole.
yeah, they call it an NRHD, which stands for,
Near rectilineal halo orbit.
thank you.
I'm reading it right
action.
off the graphic.
What's that?
I'm reading it right off of the graphic you have.
Yeah, good. My eyes are
I
losing
can't
their
read it.
acuity.
It's all a
So,
blur. It's worse than the lowest line on the eye chart at the ophthalmologist.
Yeah.
Yeah, so
Oh,
in
there they-
parallel, you also have some of the blue stuff going on with the that they're going to end up rendezvousing with, right?
well, the blue stuff is the trip back.
Okay.
So we're on the trip here, the green going down. And when we get down here, they enter into this orbit. And
Well,
so
where
then
are
you
they going to
prepare-
rendezvous with the SpaceX craft?
Yeah, that's just here, the lunar lander preparation. Lander undocking and separation from the Apollo, or not Apollo, but
Artemis.
I was showing our age.
Yeah.
About the Artemis. Then the lander enters low lunar orbit. So that's the green, and it goes around here. Oh, this is the low lunar orbit there. And
Well,
then,
I think it's this upper diagram on the right.
right. So this is the lander coming down and landing on the surface, roughly in the South Pole shown here, with the lead lander. Then the Orion remains, the capsule remains in NRHO orbit, which is this orbit.
It's like the command module in the Apollo missions.
Yeah.
Yes. So
Well,
then
why did
lander ascends to low Earth orbit. The crew returns to the Orion. Here's the Orion coming around. They join together. Then we're over here at this junction where now the final return trajectory burn, where it leaves this lunar orbit, does a close flyby of the moon, and then it heads back to Earth. And then the command module separates from the service module, and this goes in and makes goes around the Earth. Actually, you can see some parachutes on the far side.
Oh, yeah.
That's where it lands. It splashed down. So that's going to have 3 astronauts on board.
3. I thought there were 4, including a person of color and a woman.
That's 2 of them. I don't know whether it's going to have 3 or 4. I'm thinking again of Apollo.
The third person will be a wasp. This is Artemis 3.
This is Artemis 3.
All right, would you answer this? You gave quite a bit on a depot, a storage depot. Is that Artemis 2 that launches either this year or next, in between? Have some sort of storage locker hanging out up
They're
there.
going to have after Artemis 3 as part of the continuing exploration of the South Pole of the moon. When these flights are more routine, they're going to have a station orbiting the moon permanently that's called Gateway. That's not a part of this.
Okay, but you did have details on what's called a storage depot into Earth orbit. At least that's SpaceX 1, and then it goes up and around and travels 6 days. NRHC, as you said. Maybe this is all part of Artemis 3, I guess.
Yeah, this is Artemis 3. The plan for Artemis 3, things may change.
Storage depot.
Artemis 3 will not be launched this year. The upcoming event for this is SpaceX trying to get their Starship and booster operational.
We don't have an exact date in 25, a month and day.
I don't think so. It's way too early to set that.
Oh,
Okay, now we're going to go ahead.
The depot is tankers of reusable tankers of propellant, according to your talking points.
Yes.
Fuel, Are we talking about orbiting or storing on the moon's surface?
Both.
Oh, better not crash those suckers.
Better not crash any of these suckers.
I guess you're right. Fascinating stuff. We're back. Suppose the astronauts are going to have a line on their mind when they climb down the ladder like Neil did.
I don't know if they're going to have a prepared speech.
Well, one of the astronauts in Apollo read, I think, the opening of the Bible in Genesis, didn't he? In the beginning.
Oh yeah, one of them when they were on the moon, they quoted that in the beginning.
Yeah.
We're going to switch to spiral galaxies here.
All right.
Not spiral, excuse me, we're galaxies. Now this is a section, we talked about this earlier, or the question came up earlier, so I prepared this thing on ring galaxies.
Ring galaxy.
You had asked where they come from and what they are.
Yeah,
So in general, there are 4 classes of galaxies. There's spiral galaxies like the Milky Way, like us, and Andromeda and M33 behind me. And there are ellipticals like M87. It's just a big puffball of stars. They're the largest and most common type of galaxy in the rich central region of galaxy clusters. Then there's irregular galaxies, which are a third and ubiquitous type, usually distorted from a prior spiral or elliptical shape by gravitational interaction, including collisions with other galaxies.
And there's also lenticulars usually that are kind of like spirals, but without the arms.
Okay.
Without the arm, how can you be a spiral if you don't have an arm?
Well, it's like the central bulge of a spiral, but it's not elliptical in shape. It's lenticular.
Well, way back at the beginning, the Webb is seeing those 13 billion light year old ones that are just big globs. Are those the irregulars?
No,
But
they are seeing spiral structure in the James Webb ones. So that's surprising people that there's spiral
And
structure so early.
they even see these ring galaxies in very, very long ago, which is puzzling. So there's a very, go ahead.
No, I would just said, yeah, neat. Is this one we're looking at, right?
Yes, but there's a very rare type that's striking and beautiful. That is the ring galaxies. They make up about 1 in 10,000 all galaxies out there. The first one, the Hoag's object, was discovered in 1950.
That's what we're looking at.
No,
that's not Hoag's object. Let me show you Hoag's object.
But that looks like a ring. It doesn't
It
look
is a
like
ring.
it's a ring galaxy, but it's not Hoag's object.
Okay, here comes Hoag's.
There's Hoag's.
That's Hoag's object.
Well,
And,
Hoag's.
and what's cool is if you zoom in, kind of at the 12:30, 1 o'clock position there's another ring galaxy in the background.
Oh, yeah, right there. Yeah.
Wow.
We're looking
Now-
through it, huh?
What we're going to talk about is an active theory of how these form, and it explains about 70% of the ring galaxies. And ironically, Hoag's object, as you'll see, is not explained by this theory. So that one is going to remain a mystery then.
Would it be fair to call them the Saturn of galaxies instead of little pieces of ice, forming a ring? It's just a bunch of stars that do.
Well, you'll see that it doesn't really fit that as we get to it here.
Okay.
So this is galaxy 6, NGC 6028. It possesses many of the common features that characterize ring galaxies. It has an inner population of older stars in a primarily elliptic configuration, with a large separated population of younger stars in the surrounding ring halo. That is, there's a lot of star formation going on around here and not much in here. The stars are different ages and different colors, but they're found at the same redshift and distance from us. So they're part of the same object. And this is the classic, what would you say, archetypal ring nebula. Now this one, this shows ultraviolet image at left and a visible light image at right of NGC 1291. The inner disk and bar persists in the center where a population of older, cooler stars dominate. The outer, fainter ring, young blue stars dominate, having formed relatively recently.
Huh.
Now, this
So
object, the next thing, yeah, go ahead.
Everything's orbiting or turning. Everything's turning. There's no such thing.
Yes, everything, it's got an angular momentum to it.
Okay, they just don't form arms.
You'll wait. They haven't formed the arms yet, if they're ever going to. Now, this one is actually, this is not a ring nebula, a single ring nebula.
Galaxy.
It's rather,
Yeah.
What's that?
Galaxy, I'd say, rather, yeah.
Oh, yeah, excuse me, yeah. Okay, anyone want to take over the narration?
When I first saw this, I thought it was gravitational lensing.
That's what this
That's
is.
exactly what it is.
Oh,
And it might be mistaken for a ring galaxy, but it's not.
I'll be damned. I pulled it.
These are two galaxies apparently just on the same line of sight. But it gives you a nearly perfect ring, which, as you know, are called the Einstein ring, if it makes a full circle.
And that would be another galaxy behind the big bright centerpiece of that.
The ring that you see around there, this is the galaxy that is way behind this galaxy. This galaxy is in front, and it's acting like a lens that's putting this one with a lot of spherical aberration as an image in front of it.
How often is that? How often do we have that? If you can get one out, go ahead. If you can get 1 out of 10,000 are ring galaxies, and they know that, how often do we get something that we'll never see? It's always going to be a lens.
That I don't know. And it won't always be a lens. Eventually this one will move off and the lens will look to move the other way. And then this ring will go away.
You're kidding.
It's just like a lens. When you move the lens, the image changes. Everything's moving.
There's
now this is a true ring nebula. It has all the classic features of it.
Galaxy.
lopsided ring.
Galaxy. Okay. So this is a ring galaxy. You can see the star formation clouds and younger stars out here. You can see the inner core with dark clouds obscuring the core a little bit, and some faint, it's got a bar with it and some faint rings.
Wow.
But it's off center. But still it's a ring galaxy.
Wow.
Now this is the same ring galaxy.
Okay.
It's off center. But the thing is that this is another galaxy that's over here. And galaxy, there's a trail of stars between this galaxy and this one. And
Really?
this ring has formed, the information of this is from simulations, computer simulations. But this is an actual photograph of the stars. This galaxy has collided with this galaxy, but it hit the galaxy straight on, normally 90 degrees to it, and it hit very close to hitting the core of this galaxy, and then passing through. That's where these galaxies come from, is they're the result of a collision where another galaxy hits this one flat and straight on and right through the core.
That's how we get ring. That's how we get a ring. That's how we get a ring galaxy.
That's how you get a ring galaxy.
So all the arms stop, or they coagulate together and form a donut.
No.
This one, what it is the galaxy. This is the cartwheel galaxy.
Mhm.
Here's the guy that did it.
No, actually, it's the other one, the one above
Excuse me, yeah, because this one's far away. It's redshifted. Here's the guy that did it, according to this theory. And what happened was when he hit in here, the particles don't actually, the suns don't actually collide, but they have strong gravitational interactions that are very symmetrical when they hit this way. And so this is a wave like in regular galaxies, the spiral arms are like traffic jams. They're traveling clusters or clumps of material with a rotation to them. Here, the this collision has caused a central wave to go radially outward through the galaxy that it hit. And that causes this pattern that pushes everything out. And so these young stars around the edge, they're surfing on that wave from when this got hit, and the wave of particles and dust spreads out. Are you with me on that?
It's a
Bruce,
splash.
Tom and Bruce, you have a comment?
No.
No, he's doing a great job.
Well, the computer generated descriptions show them becoming a dancing, they balls.
That's different, Ron. That's not a head-on collision. That's
Yeah.
just you have them colliding in general.
They're going so
First-
fast. Okay.
The first, these are giant computers. They first started doing them back in the 80s and 90s with the Cray 1, but computers nowadays are much bigger and much faster, and they're networked in parallel, like with a Beowulf ring. I think that's what it's called, a Beowulf cluster. So they started taking pictures of irregular galaxies that were clearly the result or believed to be the results of collision. And they would make up galaxies of millions of stars, and they'd collide them in the galaxy, and then they'd play with them until they could reproduce combinations that you see and shapes you see in the sky. And it was very dramatic that they could reproduce these things. Now they've been doing this with this type of collision to reproduce what you see in the ring galaxies with modern computers. And that's, again, this is what you see when this is one that a paper has called the culprit, because it shows the actual right after the initial collision with the galaxy going through the center of this one.
But obviously
Capabilities are being delivered.
it takes millions of years, right, to go through there.
Yes. And so but as far out as this is, the collision also has sent waves out that are out about this far now. So
Hmm. Well, you know that what they look like when the computer generates the two colliding galaxies that go do spiraling weird
yeah,
patterns is a bunch of thousands of birds or even sardines schools under the water. Look very, very similar.
Yeah.
well, we'll have a collection of computer generated collision images at one of the future meetings, but none of these that I'm showing you are computer generated.
Oh, this is a real picture right here.
This is a real picture of something, and they feel lucky to have found it because it's the latter stages of the actual collision.
But the bigger one that's on the right is a ring galaxy, and the one that we're seeing edge on, is that a spiral, you suppose?
It's something that hit it. I don't know what it was beforehand.
Spiral edge on it. We're seeing it a spiral edge on, or it's an irregular. And
Yeah, and
passed through the other
it's got a lot of the core activity in here. See the red,
guy.
just like the M81.
Yeah,
maybe
cigar.
Yeah,
Hmm. But the odds of any stars colliding and crashing is just near zero, isn't it?
It's pretty small.
yeah. The thing that happens is stars come near each other, and then they whip around each other, and so a lot of stars get spread out, and they don't end up in any particular galaxy. So that I saw a video, an animation of computer generation of our galaxy hitting Andromeda. And they did it from the point of view of what Earth would see in their sky. And it's very variable. You can't tell exactly what's going to happen because you don't know where every star is going to be. And this is highly dependent on the details of that. But most of the scenarios showed our sun as being whipped off of the Milky Way and going and being one of those wanderers in deep space. It would
Hello.
no longer be in the collided galaxy. But other scenarios could happen, and it could stay in the combined one. This is a ring nebula that has
Galaxy.
Used to be nebulae, but now
that's
called galaxies.
Looks like
Yeah.
a special at Kay's Jewelers.
Yeah. Rubies on sale.
Yeah,
Yeah.
that, my first wife was wearing a ring just like that.
Yeah, this one is an unusual one. It shows what's left of the nucleus off center in the ring. It says that the actual interaction dynamics to produce this feature exactly have not been perfectly constructed. They're in process of trying to get that to happen.
You're also seeing a two-dimensional presentation of a three-dimensional object.
Yes,
That middle part, the way I look at it, it actually could be rotated out toward the viewer.
it could be. There's a lot of text discussing exactly that point that I left out. So this one is called by astronomers the perfect 10, because there's a 10, a 1, and there's a 0. This is also a ring galaxy. And this is a ring galaxy, but without a nucleus. This is in the catalog of unusual objects. This is ARP 147.
The one on the left is the one that went through the one on the right, you suppose, and made that.
That's the implication here.
Wow. They both became rings.
They both hit center on center.
Wow.
So the one stole the center out of the other one.
Yeah, I would say that's right. That's a good guess.
But they're not predicting Andromeda is going to turn Milky Way into a ring.
I don't think so. We're all tilted at each other. There's no hitting at 90 degrees to the plane of the galaxy. We're at about, I think we're tipped about 40 or 60 degrees, depending on your point of view. So anyway, the original ring nebula that we had to start with, Hoag's object, is this. They can't find anything that went through, and we're looking straight on. So this might be the back end of it, and the straight on thing is on the other side of this core. So until we spot it, they cannot reproduce this ring with what they see in the picture around. So Hoag's object remains a mystery.
Well, can you answer me this? The round part in the middle seems to be sending the redshift at us. Why wouldn't it be a distant galaxy, that one that went through and it's going away from us?
That's the color because of the age of the stars. They're low temperature.
Right. So as pointed out earlier, these two, the ring and the core, have the same redshift. So they're the same distance from us. So they're in the same object.
Well, I sure don't see much red in the ring.
Well,
No, there's not.
that redshift is very subtle in this case, unless something really, really far in the
redshift, it doesn't
background.
mean things turn red.
Yeah.
But newly made stars emit or radiate more ultraviolet, and old stars have gotten rid of all their ultraviolet and they're stuck
Well,
with red.
young and massive stars, which is what you have in the ring, are blue because they're hot surface temperature, because they're massive. But the core has these older stars that, the ring stars will only live for 10 million or 100 million years, whereas the stars in the core are living for billions of years, and they're low mass. That's what's left. Okay. And so they're low temperature and they show up as yellowish.
Uh-huh.
So this is a single photograph in visible light. There's no infrared or ultraviolet in there.
Oh.
So there are mysteries yet to go.
Yeah.
I'm a big fan of computer simulations. Anyway.
Well, if there is any intelligent life on their stars, they probably don't care. It's probably just as same as here, only they're probably aware they're in a big ring instead of a
Maybe.
stars.
Okay,
We
the
got
next topic is 2 visible solar eclipses that are coming up in the next 2 years.
You got it, Easy Rider, upcoming.
Okay, now this shows the Earth, half of the Earth, and the moon's orbit. And you can't really see it so well here, but this is closer to the Earth than here. And the apogee is farther away from the Earth. This is a representation of the moon's actual eccentricity. So sometimes the moon is closer to the Earth, sometimes it's farther away. That's the takeaway from this chart.
And it's not always along the line to the sun like the shading here would implicate.
Right.
But obviously, if it's on perigee, we get a more full solar eclipse, wouldn't we? Because it's in closer and thus bigger.
Yes.
Well, let's explore that.
Okay.
So here it shows the apparent size of the moon when it's at perigee. And here's the moon at apogee. See, it's smaller than this one.
And by the way, that perigee moon is now what everybody hypes up as super
Right.
moon.
Yeah.
As what moon?
Super moon, when it's a full moon at perigee.
Yeah.
Really? You can tell? I can tell with these pictures, but I wouldn't be able to tell you on a
Right.
perigee night.
It's hard to tell naked eye, but the media hypes up full moons near perigee as super moons.
Right.
But that's where we get the extra side types of solar eclipses, right?
Combination of two things. See, the sun also does this too because the Earth's orbit is elliptical.
Mhm.
So this is the sun when we are at perihelion, that is nearest to it. And this is the sun when we're at aphelion, farthest from it. See, our average is 93 million miles. This one is 94.5, and this one is 91.5 million miles. So depending on where the sun is and where the moon is in their orbits, when the moon covers the sun, if the biggest moon covers the smallest sun, you get the longest totality of a solar eclipse. If the smallest moon covers the biggest sun, then you cannot cover the sun completely. You get an annular eclipse. We're having an annular eclipse in this year, 2023, and we're having a total solar eclipse, this version, in 2024.
Right, it goes right over my
US.
hometown, Jerry. Goes
Does
right
it?
over Indianapolis. Yeah.
Really?
In April of next year.
Yeah,
But the annular, we get to see a corona.
no, annular, you get to see the edge of the sun,
Right.
Isn't
not
that
not so easily the corona.
I
Yeah,
thought
it's a
you'll
total
see
when
the-
you see the corona.
Yeah, we'll show that. So this is the one in
October.
oh, there it is. Yeah, October 4th. I made sure each one had the date on it, and now I can't find the date. Okay.
October 14th,
October
it's in
14, 20.
the big thing up there.
But at least it's not a ring, a nebula.
Yeah.
So this is the path of annular eclipse of the totality. And you see that it goes up from Western Oregon, northeastern Nevada, over St. George, Utah,
Mhm.
and down through New Mexico, Texas, and off, what is it, Corpus Christi is around this area.
Oh, yeah.
Yeah, that's about right. Mhm.
And so then these are, if you're farther away, like we're up here.
Mhm.
So we're going to see on this line, we're going to see a 70% coverage of the sun, but it will
Yeah.
not be total here. We'll see a sun like a crescent.
Hmm.
Any questions?
This is an annular we're looking at,
This is an annular.
Yeah,
which means the moon is closest or farthest.
Means
further.
it's going to look like this. The sun is closest and the moon is farthest.
Got it. That means.
This is a photo I took of an annular eclipse in St. George, Utah.
St. George. You're in love with St. George.
Yeah, yeah.
It's a neat town.
It is a neat town. 2012, when I went there
Mhm.
in April, I think it was sometime like that. They had just had a bunch of floods that winter, and houses had been floated away on the river. So it was an
Whoa.
ugly time for the
That would have
town.
been probably the Virgin River, Jerry.
Yes, that's it.
Yeah, it goes right through St. George.
Yep.
Yeah.
And this was I took this with a Lunt solar telescope, 80 millimeter, and a Canon DSLR. And you can see here, you can see prominences,
Yeah, it's
not
nice.
because of the eclipse, but you see prominences because of the hydrogen alpha telescope I was using.
Mhm.
And you can't see any corona.
So what is the corona?
The corona is the atmosphere up here, highly structured by magnetic field lines.
A million degree Fahrenheit or centigrade atmosphere.
Yeah.
Yeah, it's what we studied at the Lockheed Research Labs in Palo Alto.
So anyway, that one now in 2024, We're going to
Ah,
have.
there it is, right over Indy.
There we go.
This will be a total.
Yes,
Yes.
this will be a total one.
Yeah.
And you can see the darkish patch in here, the ellipses. That's the duration of total. Up here, oh, this is the spatial distribution of total. Here it's going around the curve of the Earth, so it's hitting at an oblique angle, and so it gets so longer. You see it longer. So where is Indianapolis?
It's next to
Right in the
Indy.
middle of right in the middle of Indiana. So you're close.
Down a little tiny bit there.
Yeah, I can
Down
see
this way.
Columbus, Ohio.
I see Chicago.
Yeah, so
And,
to get yourself on I-65 in Chicago and go south.
okay, so down here.
Yeah, you're about there. That's about
Yeah.
it.
Okay. So it's not going to be very much of anything here in California. We're way out on,
It's like 45%.
yeah, something like that, 45%. Yeah, this is 45%.
Yeah, it comes
So-
in through Texas and goes away in Maine. That's
Yeah. So for us, if you want to get a good view, you're going to have to go down to somewhere like San Antonio
Yes.
or Austin. Those are actually on the edge. I'm sure there's some smaller town in here. You can
I
get
think
to.
Fredericksburg, Texas is one of the places very
Okay.
close to the center line.
So finding a place to go is a exercise in psyching out the weather by looking at traditional weather in past years and probability that it's going to be clear, but always keeping in mind that the eclipse itself changes the weather.
Yeah.
So,
You listed,
Oh.
Mr. President, you listed 3 and hybrid is the 3rd. Is that the edge, not in the direct path? That like
No.
us?
so hybrid, as these things are going around in their orbit, they're changing their distances. And so there's 2 kinds of hybrids. One, you can start with the moon looking smaller than the sun, so you get an annular eclipse, but then farther along the eclipse line, the moon has moved closer and now it's bigger and now it completely totally blocks the sun.
Okay,
So it changes from being annular to total or from total to annular. Those are very rare.
but now that pathway we're looking at on this map that goes
Yeah.
southwest to northeast,
Yeah, goes this way.
that is the path of the moon, right? Out there at the
That's
edge.
correct. This is the shadow, the darkest part of the shadow of the moon.
All right, does it ever go just west to east or northwest to southeast? Does it-
It's always generally west to east.
Okay, and it varies that much, and I thought we had a nice even platter, ecliptic, if you will, of the moon's orbit that would be like above the equator. It doesn't look like it at all with this.
No, this is all above the equator.
Hey, Jerry, I can now see Indianapolis on your thing. Put your little hand on Chicago. Okay, now go down and to the right and put your little hand on Cincinnati. You're right on Indy right now. You're right on it.
Okay. Okay, good. Thanks.
Yeah.
We could go to Indianapolis and do that.
What's that?
Let us know, Whittemore, who your relatives are, and we'll make reservations.
Show up on their, they have a
Yeah,
guest.
you know, the weather in April in Indianapolis can be absolutely beautiful, but also could be rainy.
Jim
Okay,
Williams is watching, and Tim just relayed that Jim says he's staying at a friend's house in Texas that's right on the total line of totality.
Okay.
I
What
see.
town is it in? What town did he say?
He didn't say no.
Okay.
No, he's
Well,
not going
anyway,
to
this
get
is-
that away.
This is April 8, 2024.
Yeah.
For those, okay.
Watch us have rainstorms like we've just gone through, covering the whole East Coast.
It's pretty
Well,
nice.
this is a picture that I took from Queensland, Australia
Mhm.
in November 2012. And this shows the corona. You see the atmosphere out here? And it looks like it has wisps of hair like lines. Those are the magnetic field lines lining things up. And you can see prominences on the edge now here. And this is due to the moon blocking it now, occulting the sun, not because I used an H alpha camera, because I didn't use an H alpha. This is just a regular, actually it's an 80 millimeter Orion ED 2-element refractor on my Canon DSLR. I think it was a D40 or 40D or something like that.
Mhm.
Worked great. And then this is
Oh, a Bailey's bead.
Diamond ring.
this is a part
Yeah.
of the eclipse where it's called the diamond ring.
Mhm.
And this is the sun making its first appearance after the eclipse is over. It's just starting to show. And then immediately it brightens up in a big crescent ring, and then you can see the whole surround. So this is the point where you take your last picture and you grab your filter and put it on the camera or put it on the telescope so it doesn't burn a hole through the back of your camera.
Yeah.
That's what an H alpha is? It's
No.
filter?
Oh, yeah, it is.
Yeah. No, the filter I'm talking about in this case was a neutral density filter made by Thousand Oaks Optical.
Mhm.
But an
So
H
this
alpha
is-
is also a filter. It's just they're usually
Yeah.
slightly different designs of filters.
Yeah. So this one, everything you see up here is simply due to all the corona and the edge of the sun being red is due to the eclipse, the occulting of the moon. It's not due to being through an H alpha telescope. But you don't have to wait for an eclipse to see the prominences. This is here where you get them with an H alpha scope.
Where everything is basically a red color.
Yeah.
Yeah.
Hydrogen alpha is where things are, where that's what's happening on the sun.
Mhm. Yeah.
So
Can
you
you go
can
back
get
to the,
you can get other colors too, like calcium, which is kind of a greenish line, but it's much fainter. It's much harder to see things.
Jim Williams has revealed the name of the town he's going to. It's called Round Rock, Texas.
Okay.
make a Western movie there? Can
Named
you,
after the moon.
Right.
can you go back to the ring, the diamond ring one you just had for a second, Mr. President? I got one question. Yeah, that one. Would it be fair to say that the moon is probably moving to the lower right?
Yes, that's exactly what's happening.
Uh,
Or you could also get this effect if it was moving from lower right to upper left, and it's just the last bit of sun you see
oh
before
yeah.
totality.
Right. There was a diamond ring down here when totality started, as Chuck pointed out.
Mhm.
Okay.
Now, when we took these things, let's see what time have we got. I'll get lost again.
I just wonder when do you zero in on the eclipse? The minute it goes dark so that you don't blind yourself or ruin your camera? Or do you focus?
Yeah.
Good question.
Before it's covered and use your H alpha or whatever, your filter to, otherwise there's a tenuous time period in there that you can really, you got to get it taken off the sun the minute it starts to beam again, right?
Yeah, you got to be a
Right.
little bit careful.
Yeah.
Okay.
It's pretty dramatic. I know, Chuck, you were up in Wyoming at the 2017 one, right?
Yes.
Yeah. I was in Greenville, South Carolina. It was spectacular. We showed it to a whole bunch of kids, and we gave them safe glasses and things like that. And I made little pinhole cameras for the kids. It was pretty
We were
fun.
at an event center in Casper, Wyoming, and there were
Okay.
like 5,000 other people there. And so whenever there was, a diamond ring or the beginning of totality, end of totality, there was just all this whooping and hollering.
Yeah, right. Yeah. We were at a small church in Greenville, and there must have been about 100 people.
Can you see this?
Yes.
Yeah.
Huh. Okay.
Curious how you block out the sun. Is there a little spot on your camera or your lenses somewhere, either the front or the back?
That's the
No,
moon blocking the sun.
It's the moon.
Okay, here's me and my wife in a cow pasture,
Mhm.
and along with 137 other close friends.
Mhm.
This is the camera set up. There's just a telescope and a filter, a neutral density filter. This is the sun rising in the east
Okay.
over the eucalyptus, and you can see a lot of clouds here. And it clouded up very much before the eclipse started. And actually, they go this way. This is the longest exposure to get more of the
Corona.
and here is a shorter exposure to get just the core of it. And here's a very short exposure to get the core. Here's the diamond ring effect that I showed you at the end. And here's after the end. And you can see that the clouds here are reforming. The clouds went away during the eclipse. So it was cloudy before and everybody was moaning and groaning. And this was the ranch we were at. Cattle ranches in Australia are called stations. So this was Weatherby Station. And so when the eclipse started, the clouds cleared up and went away. We had really nice skies. And then afterwards, all cleared up, it all clouded up again.
Before we go, I just have one question. Does anybody think to bring for their sound system to one of these events also Sprach Zarathustra and just crank it up? You know,
I think to do that, I think we have to get permission.
Probably right. Well,
No one did that. We were all focused on the store. I have about a 5-minute video that someone took of that eclipse. I can show it to you sometime.
I'd love to see it.
Yeah.
We have run out of time, gentlemen. Happy 100th show and happy Tim Crawford birthday. And we'll use his cake to celebrate and gather together in a week, shall we?
And Tom, Tim is saying good luck to Tom for your hip replacement.
Thank you. That's on Tuesday, but I plan to be here on Monday.
Oh my
Okay.
God.
I hope you're here on Wednesday too.
So they'll be giving you a loaner. Oh, no, you're getting a new one. All right. That's great. And glad you're back with us, Bruce, and give your
Yes.
love, my love to your wives. And we'll see you on this screen again in a week for the
All right.
SBAU
Sounds
Astro
good.
Hour. You did good. I learned a lot.
Thanks.
Thanks. See you.
All right.
Bye.
Take care.